Hello everyone. Hello everyone. This is Luis. Now we're going with the second part, second chapter of our streaming. We already paid a subscription of Data Camp for 1 month. I guess just 1 month because then I'm gonna jump into deeplearning.ai, and I guess that for 1 month it will be good to finish the whole AI associate for developers. Okay, I'm gonna make sure that the whole screens are good. Yes, good. Then I'm also gonna go to my live section just to check. I'm just gonna check that everything is set up, that you can hear me properly, and that everything is properly set up around here. I'm gonna check here. Around here. Yeah, it's good. It's good. Everything is good. So we're ready, guys. There's now we're going to the second part because we already finished the introductory part, which was like basically set up, like learning where to import the package from OpenAI. Also like making some basic prompting with in Python, setting up everything. Now apparently we're gonna make summarization and editing text. So we're gonna start with the lesson. Yeah, let's go.
In this chapter, we'll explore the range of tasks that can be performed by OpenAI's chat completion models. So far, we've used chat models to answer questions or follow simple instructions. Now, let's use these models to transform text with text editing and summarization. First, let's explore text editing. Let's use a chat model to update the name, pronouns, and job title in a biography. Notice that the prompt starts with the instruction, then the text to edit. We've also used triple quotes to define a multi-line prompt for ease of readability and processing. Then, as before, we send this prompt to the chat completions endpoint under the content key of a user message. Voila, we have our updated text. Even with a find and replace tool, this task would normally require us to specify each word and its replacement. This approach is much more flexible. Next, let's explore text summarization. Imagine you work for a large company with millions of customers. The customer support team asks for short summaries of customer chats to track performance and improve customer satisfaction. They provide a chat transcript stored as a string. To summarize it, we'll craft a prompt that clearly asks for a concise summary, and use an F string to insert the text variable. F strings are denoted with an F before the opening quote, and they essentially convert Python objects into strings and insert them in one go. We pass this prompt to the model, and there it is. The AI generates a clear summary, allowing us to grasp the conversation's main points without reading the entire transcript. Imagine how helpful this would be when dealing with thousands of support chats. What if the generated summary is too short? By default, the API limits the response length. The max completion tokens parameter can be used to control the maximum length of the response, shortening or lengthening it. Tokens are a unit of one or more characters used by language models to understand and interpret text. Here we can see how the model would encode this sentence as tokens to process it on input. When we set max completion tokens, it's an upper limit on the number of tokens the model will output. Now let's talk about cost. Outside of this course, the OpenAI API incurs a cost based on the model and the number of tokens processed. Each model has a price per token, and input and output tokens may have different costs. So increasing max completion tokens likely means higher costs per request. Let's calculate the cost for our previous summary request, with a max completion tokens of 500. First, we need the price per token for input and output tokens. Since OpenAI's pricing is per million tokens, we divide by 1 million to get the cost per token. We also need the total number of tokens used in the request. The input token count is found in the API response under usage.promptTokens. For output tokens, we typically assume the max completion tokens value as an upper bound. We multiply each cost per token by the number of tokens and sum the result. This request costs about 1/10 of a cent. That's small, but for longer documents and different models, costs can very quickly add up. Always estimate costs before deploying AI features at scale. Now it's your turn.
Nice, I got it. Okay, it says now here, find and replace tools have been around for decades, but they are often limited to identifying and replacing exact words and phrases. You've been provided with a block of text discussing cars, and you'll see use a chat completion model to update the text. to discuss planes instead. Updating the text appropriately. If you send many requests or use a lot of tokens in a server, you may hit your red limit and see an open red limit. Okay. Okay. So basically, there is this prompt, and in this prompt, they're talking about cars, and we should make it to talk about planes. A car is a vehicle that's to become. All right. I mean, normally, like when you will do that in the way that you will do this in the not using AI is probably you will just get a regex and just try to find the coincidence of cars and then update it with planes. But that will not like also change because probably when I send this into the AI, it will not only change the words of car just to airplanes, but it will also change the definition of what we're talking of. For example, it wouldn't say it has four wheels, and this is something that we cannot do in regex probably in a deterministic way. So this is really interesting because with AI with an LLM you can do that. So in here I remember you. Okay, you can here put the prompt. Here it should be message. Assume. Wait, let me check the code here. Okay, let me check the code. Role and content. Sorry. Role and content. And okay, baby. Let's make why we need okay first max completion tokens. We'll make that 100. So that's good there. And then into the prompt, we need to create another one called replace prompt, which will basically take I will make a multi-line here. I'll put the prompt here. I don't know if this is the correct okay, I'll try to do it in my way and then I'll just paste it into Cloud too so I can get the corrections. So okay, so I'm gonna write analyze the okay, right. The following text is talking about cars. Please restructure the text so it talks about airplanes. Alright, and then I'll put the prompt. Then instead of sending this prompt here, I will just put the replace prompt here. Then here, according to here, I just need to get the message content. Yeah, and then I'll run the code and see what it gets. Okay, I was confusing with JavaScript. This is the correct. With underscore. So it's max underscore completion tokens. Okay, so let's run it. Yes, and that works. It works and it works good. I'm just going to now make a replacement of this. It's gonna be 4, and it's gonna be called text placement. Then it's gonna be the same configuration until here, and then here I can copy the prompt and the replace prompt. If I do this, yeah. Maybe at some point I will just refactor all of this so it has the import into some. All of this code should be like just one import somewhere, so I don't need to redo it every time that I'm creating. But let's focus on the AI, not in the software engineering so far. Okay, so let's submit. It says, did you configure the prompt as messages to send to the chat model? What do you mean? No. Yeah, the prompt must be configured inside of a series of messages. So I should do it in more prompts? Or what do you mean? So I guess it's asking me to make like. So I guess it's asking me for. Okay, let's do. Okay, so then let's make it like this. The previous. So I guess it's asking me to put like more messages. The previous text is talking about cars, so it talks about airplanes. So I assume that what it wants me to do, it's something like prompt, and the replace prompt I send two messages. Yeah, I assume it is wanting me to send this. Yeah, I will probably do this. Nope. Again no. Okay, let's start. I'm getting this error for this code. So Okay, maybe I'm doing the replacement there. What about this? Ah, so maybe they want me to put the. So what will be the full code then? So basically, okay, so I don't need, okay, I didn't read this stuff. So the prompt was already there, so I don't need to make another replacement prompt. I'm just gonna run the code and I'm gonna get the same answer probably, yeah. And then I just submit the code and everything should be good already. Okay. So, I mean, I didn't need to create a replace prompt because basically the replacement in the direction it was here. Okay, my bad, I didn't read. All right, no problem. Then I'm gonna also run it here. So I'm gonna run the number 4. Yeah, it replaced. Now it's a vehicle distributed for jet engines. It has wings designed to carry passengers and cargo through the air. Good. Works good. So we'll commit later when we finish this whole chapter. Text summarization. One really common use case for using OpenAI models is summarizing text. Okay, this has a ton of applications in business settings, including summarizing reports into a concise one-pagers or a handful of bullet points, or extracting the steps and timelines for the stakeholders. You will summarize a passage of a text on financial investment, finance text. Okay, so probably this finance text is already defined in the environment, and I need to define the max. Where was it? Max tokens allowed. Max completion tokens. It's equals to 400. And that's pretty much, I guess. Uh, okay. Okay, I guess this is something about the data camp. Uh, if I should be good, and this is the same, which will be summarization. The thing is that probably this summarization is good like this in double M. Sorry, my bad. It's the English. I speak natively Spanish. 5 text summarization. Good. So I'm just gonna copy all of this. I'm gonna put it from here. Then, because of the fact that in our local code there is no finance text, I'm gonna ask like another chat. Generate a random, let's say, one page finance text about AI impact on financial world in 2026. You are a finance expert. So now I'm generating a sample, so it's just there. So I just copy so it works like good. This might take a while, but then I'll just define a finance text. It's equal to whoa. It's markdown. Give it to me as okay, let's see. I'm gonna copy this. I guess good. I guess good. I mean, it's a really big. We should put it like somewhere outside, but just for the sake of like testing, I think it's. I think it's good. Python 5. Okay, this is not good. Text summarization. There's a space here. Need to be really careful about that. So it's gonna take like this whole text and make a summary of it. Cool. AI has going to investment, new risk, small concentration, enabled fraud, emphasizing importance, human accountability. Cool. So it worked. It's nice. Let's continue to the new lesson. Okay, calculating cost. Before deploying AI features and skills, is to estimate cost. The cost depending on the number of input and output tokens and the model chosen. Your task is to calculate the cost and summarize the customer chat transcript. Okay, I guess that the input tokens will be the whoa. I need to have good memory for this. The cost we input token set the input token price. And the output tokens times the output tokens price. I guess everything is good here. I just need to I'm gonna do this code. How to get the number of input tokens. Usage prompt tokens. Got it. So it comes into the usage. There is autocomplete here. No, there is not. right. So that should be the coast when I get the response. Then I run it. Name response is not defined. What do you mean response not defined? What is here? Unless I'm using it somewhere and I'm not declaring it. No. It's really funny. It's not running, but the answer seems correct. Okay, maybe I'm gonna reload. Maybe something about the sessions. I don't know. Now run. Now it appears to be good. So then I'm gonna duplicate this. It's gonna be 6, and it's gonna be price calculation budget. Token price calculation. And I'm just gonna copy this. Then this is gonna come here. There is a perpetuity of $100 a month. That is the current value. Just a random question. I just want to make sure that it calculates good in my local. So I will need to do Python, and this is 6. Oh no, wait, stuff. Max completion tokens is not defined. Because I didn't, okay, I need to define this too. And I guess that this is, I can just put like 100. I didn't save. Let's run it. Now it's good. This is 0.00006 dollars. It's less than cents of cents actually. This works. It's good is to calculate the cost. Now with text generation, welcome back listener. Okay, Let's watch the new lesson.
Welcome back. Let's now explore text generation and its real-world applications. When we send a prompt to a chat model, it returns the text that it believes is most likely to complete the prompt, which it infers based on the data the model was developed on. If we send "life is like a box of chocolates" to the model, it correctly completes the quote with high probability. We say high probability here because the model results are non-deterministic, so we cannot guarantee the exact same output every time. There are many use cases where randomness is undesirable. Think of a customer service chatbot. We wouldn't want the chatbot to provide different guidance to customers with the same issue. However, we would like the model to be flexible to different inputs, so there's often a trade-off in the amount of randomness. We can control the amount of randomness in the response using the temperature parameter. Temperature is set to 1 by default, but ranges from 0 to 2, where 0 is almost entirely deterministic, and 2 is highly random. If we add a temperature of 2 here, we can see the model completes the prompt in a more bizarre way. As well as completing prompts, text generation can also be used to create brand new content. For example, let's generate a tagline for an electric car. A well-crafted prompt should be clear and detailed to guide the model's response. Here's what we got. That's not bad. We can also tweak temperature and max completion tokens to experiment with different ideas. Another common use case is creating product descriptions. Here, we'll create a description for a new smartwatch aimed at fitness enthusiasts and busy professionals alike. We start the prompt with the product features and finish with instructions on the desired tone and target audience. Passing this prompt to the chat model in a request, we get something that already looks good enough for any e-commerce website. If we need to iterate further, we can always update the original prompt with more specific information and rerun our request. In the next video, we'll explore how to provide examples to the model, which can improve text generation consistency. But for now, enjoy exploring use cases for text generation in the exercises.
Oh, that's good. So basically, it's just something about the temperature and the max number of tokens. The more close to zero you get the temperature, basically you will have more like deterministic answers. Meanwhile, when you make the temperature higher and higher, you allow the LLM to be more creative, let's say, and have like many different answers to the same questions. Got it. So content generation. AI is playing a much greater role in content generation, from creating marketing content such as blog post titles to creating outreach emails for sales teams. In this exercise, you'll harness AI to generate a catchy slogan for a new restaurant. Feel free to test the different prompts, such as variant the type of cuisine or the type of restaurant. See how the response changes. Okay, max completion tokens. Max completion tokens. Let's put it to 100. And then you are a marketing expert. Please generate a new slogan for an Italian restaurant. Let's say specialized in fine dining. Oh, it's taking a lot. Meanwhile, I'm gonna copy this. _content generation. Why is it taking so long? It's not good. Let's restart the session and let's just run it here too. This will be Python 7. I guess that if I will give it more completion tokens, it will be like larger. And if I assume that the next exercise is about the temperature. I'll just run it here. Client is not defined. Okay, I need to reload the page. This is really annoying. You need to fix guys that you need to fix these guys from data camp. Just from time to time, I think the token of the session is like reloading. So it's not, I need to reload the page. I'm just gonna copy my prompt from here. Max completion tokens. This is getting really slow here. Well, if this is happening, and then what I'm supposed to do, like, reload again, I guess. Nope, it's not really. It's not giving me a break. Let's reload from here then. Why is it not loading? Okay, but it works in my site, so maybe some problems in the server or in this chapter. I don't know. I'll just jump to the next. I'll just jump to the next one. Generate a product description. Okay, imagine you're writing a marketing copy for Sonic Pro headphones. Your goal is to generate a persuasive product description using the OpenAI API. Test how different prompt techniques, response lengths, and temperature settings. Yeah. So I can set up. Okay, finally here it is. You can set up the max completion tokens and the temperature. So let's make it like 300 probably, and the temperature, let's set it up to 1.5. So it's like super creative. And then here in the prompt, I'm gonna, you are a marketing expert. You are, let's just go until here. So you are writing a marketing copy for Sonic Pro headphones. Your goal is to generate a persuasive content, persuasive product description. The copy should mention, and I'm gonna copy this active cancellation, 40-hour battle life, unfoldable design. Yep. And now I just induce a new parameter here. So I'm going to do this 8 And what is this? It says generate upload description. Yeah, it's good. And then here, I'm just gonna copy the prompt here. And now I realize that this is really important that I have done this locally, because if not, I will be waiting like forever until this problem fixes, until this like loading issue is getting fixed. And I cannot wait for that. Life is too short. So here's the, just for better readability, I'm gonna do this. Yes, good, good. Prone the temperature. Item 8. Ah, okay, it's giving me because I didn't save the response. Okay, now we're gonna see what it generates. 300 is not too much. No, maybe I should put like 500 or something like that to make it like really long, because this is a product. Oh, that's good. Experience the sound like never before with Sony Pro headphones. Nice. That's cool. That's cool. So it works. And here we are, still waiting for the. Not good, guys. Anyway, later we'll put those one. Okay, now about the shot prompting. Shot prompting. Let's see what it says.
We've seen how OpenAI models generate text and respond to prompts. But how do we guide the model to produce better, more accurate responses? Providing examples in a prompt helps the model understand what we expect. This technique, called shot prompting, plays a huge role in shaping AI responses. Let's break it down. Shot prompting means including examples in a prompt to guide the model's response. There are three main approaches. Zero shot prompting gives no examples, just an instruction. One shot prompting provides a single example to guide the response. And few shot prompting includes multiple examples to provide more context and improve the model's understanding of the desired output. Adding examples improves AI performance. Shot prompting helps in classification to sort text into defined categories, sentiment analysis to identify opinions or emotions, data extraction to extract specific information from unstructured text, and much more. Let's see it in action. Let's use a model to analyze restaurant reviews and assign sentiment scores from 1 to 5 to each review, 1 indicating a poor experience and 5 indicating an amazing experience. Here we provide no examples for the model, only an instruction clearly indicating the task and the labels to use, the numbers 1 to 5. Sending this request and extracting the result, we can see that the model assigned the number 3 to each review, but also appended neutral after each score, which we didn't really want. Let's now add an example before the 2 reviews we wish to analyze. This is a one-shot prompt, as 1 example is provided. We also add arrows after each review and the number 1 after the example. This should make it clearer for the model that we're only looking for the number. Running this, we see that the formatting is now followed perfectly. We can also see that the scores have changed, so providing an example gave the model extra context about how to determine the score. Let's step this up a gear and add 2 more examples, so there's 3 in total. We now have a few-shot prompt to send to the model. With this, we have totally consistent formatting, and the scores are becoming more reasonable. With even more examples provided, we could see greater consistency in the way these scores are assigned. Try experimenting with 4, 5, or 10 examples. These models can not only assign sentiments, but any form of categories. Here, we want to categorize animals into those that live on land, sea, or both. With no examples, we again see that the model provides extra reasoning that we didn't explicitly ask for. We also got a spurious result, with the model assigning both to salmon, getting confused between land and sea, and freshwater and saltwater. Let's immediately jump in with 2 examples, zebra and crocodile, and add equal signs to indicate how the result should be formatted. Rerunning the prompt, we can see that the formatting is perfectly consistent, and our spurious result has been fixed. Hopefully you're starting to grasp just how many problems can be solved using the OpenAI API, and how important prompts are to obtaining good results. Time to put this into practice.
Nice. So it's basically you need to give with the zero shot, or sorry, the few prompt or the one prompt, you are giving like some references in which you tell examples of inputs and outputs. So based on that, the LLM process your request. That's basically it. Okay, now we're going to zero prompting with reviews. So I'm gonna 9 0 prompting with reviews. Okay, so it says opening my reviews for classification tasks, categorization, and analysis. 1 to 5 positive. Okay, so I guess I need to put here classify the following reviews using the numbers from 1 to 5. And here I can just put it from here. And then I can save it and run it from here. Oh, I didn't complete this one. That's good. Catch. I forgot to put the prompt there. Save and run. Okay. With previous references, it classified each one of the reviews from 1 to 5. It's okay. It worked. No. Here, next exercise. Okay, now one-shot prompting. As you saw, there's room for improvement using prompt. Try an example. Love this is 5. Okay, let's do this. Love this. It's equal 5. So I'm giving this as a reference, and then the LLM will need to assign the numbers given these ones. And then we're going to compare it with the previous result. Okay, so we're going to do this here, and then one shot prompting reviews. So in this case, I will do this. We will here. We're giving one example, and we're gonna the LLM is gonna give us the classification for the other 4 reviews. We're gonna save it. This is the number 10. 10. Python 10. Yes. See, I mean, this is really interesting. The only one that had a different answer was this one, the last one, which is can't wait to show them off. Yeah, this person put. I mean, in the previous one when there was zero shot, it was 4. But yeah, I mean, I think it gets more accurately. Can't wait to show them off. It will be 5, not a 4. Yeah, because there is nothing bad about that. I guess that it's everything below 5, which is 4, 3, 2, 1. It should be at least something bad, right? So yeah, it works good. Now I need to go to the next one, which is few shot prompting. So in this case, I will add not the one. I mean, now we have the love this, which is 5, and now we'll add another example, which is this. And then we're gonna few shot prompting reviews. And then I'm gonna copy these until here. C11. So I'll do here return 11. So now if I'm giving 2 examples, then the answer should be more accurate, technically. Okay, now the difference now is with the number with the before the last one, which is the shoes look nice, but they aren't very comfortable. Before it was 3, which is like in the middle answer, but now it's a bad review, which is 2. And in the first one, it was 3 still. So yeah, I guess it's trying to, when you give much more examples, it will try to find similarities between your examples, and it will give you a more accurate like result. Okay, good. Let's go to the next one. Chat role and system messages. Okay, let's see how
Welcome back. In this video, we'll learn to unlock the full capabilities of chat models from the OpenAI API with chat roles. Let's get started. So far, we've used the chat completions endpoint to perform a number of tasks, including text generation and transformation, and classification tasks like sentiment analysis. These are so-called single-turn tasks, as there's one input and one output. With chat completion models, it's possible to also have multi-turn conversations, so we can build on our previous prompts depending on how the model responds. Roles are at the heart of how chat models function. Up until now, we've only used the user role in our messages, but there are also system and assistant roles. The system role allows us to specify a message to control the behavior of the assistant. For example, for a customer service chatbot, we could provide a system message stating that the assistant is a polite and helpful customer service assistant. The user role is used to provide an instruction to the assistant, and the assistant role is attached to the model responses returned back to us. Interestingly, we, the developer, can also provide assistant messages in our requests, which serve as examples to help the model better understand the desired output. We'll discuss utilizing assistant messages in requests and building multi-turn conversations in the coming videos. For now, we'll focus on the powerful system role. Here's a typical chat request that we've used for single-turn tasks. We've passed the messages argument a list containing a dictionary with role and content keys, where the prompt is sent with the user role. To include additional messages, we extend this messages list to include multiple dictionaries, each with their own role and content. These messages often start with the system role, which sets out how the model should behave. Here, we instruct the model to act as a Python programming tutor that speaks concisely. We then follow this up with a user message asking a programming question. Let's add these messages into the request code and print the output using the same attributes as before. We can see the assistant stayed true to the system message, only using a single sentence in its concise explanation. One major challenge when interacting with AI systems is misuse. For example, if we were designing a chatbot to help students study for finance exams, we wouldn't want this chatbot to provide specific financial advice or encourage particular investments. We can use system messages to add guardrails, which are specific restrictions on what the model can generate. Let's build a system message for this application. This message starts with a sentence outlining the role of the model, a finance education assistant, and its task to help students study for exams. The next section adds the restriction that if the model should be asked to provide specific, real-world financial advice with risks to their finances, it should respond with an apologetic message. Adding our system message to the request, along with a user message.
Just in case to summarize here, like when you send messages to any LLM, you can send many roles, right? Normally, so far we have been using the role of user, but basically there is a role that you can define a system, which is you can define the behavior of the systems. For example, if you want to want to have a generalist answer, you don't need to put the roles. You don't need to put an initial role system message. But if you want to be your response from a more specialized context, let's say. For example, if you want to, if you would like to make something about some code, and if you don't insert a message with the role system that said, hey, you're an expert, for example, in React, and I need you to create a React application, then it will not respond from a React expert, but it will respond from a generalist point of view. So the idea is that you assigning a proper role and proper definitions of how does your assistant should behave, then you will have you will have a more deterministic answer and you will have less hallucinations. That's the idea of that.
Asking for stock investment advice. We can see the model responds with what we wrote in the system message. Let's give this a try in the exercises.
Okay. The chat completions endpoint support 3 different roles: system, user, assistant. Okay. So I guess I need to define here system, and then user content. Message, and then content. So this will be number 12, system messages. And this will be here. System messages. So I define here the role. There's gonna be a study planning assistant. So it's good. Number 12. I want to learn to speak Dutch. All right. So I'm gonna run the 12. So technically, this is gonna, like, if I am telling the system that is like a study planning assistant, then it's gonna give me a plan. So how I can learn Dutch. So let's do that. Oh, nice. So it's giving me like, so I guess it's limited to the 150 tokens. I just wanted to make sure that it worked. It's good. I'm not gonna run it again more because probably if I need a full plan, I will need to define more about what I want to learn. What is my methodology that I'm more used to, and I only need to put like more tokens, but I don't want to use it because we need to save tokens for later for something more complex. Yeah, so it's good. So let's go into the next exercise. Guardrails. One of the most popular systems is to add guardrails, which place restrictions on the model outputs. Okay, if these skills are not related to language. Okay, so basically it's putting restrictions on the model. I guess here if I send something like, I put here system and I'll put like this message here. For example, help me learn to climb a mountain. Then in this case, like I'll get this other message that says like we no longer support. So I'm gonna do 13, and this is gonna be guard rails. If my English is correct, guard rails. Guard rails. So then I'll just go until here. Here. So in this case, I should get a message that says like, apologies to focus on languages. We're no longer creating longer plans for topics. So I'm gonna run that. 13. Yeah, that's correct. But for example, if I'll like do something about help me learn Spanish in 6 months, then I'll get a proper response. So it's basically putting a limitations on that, not to the restrictions to the model. In this case, probably will give me like a plan, but in the other one, yeah, I'll just receive the message. See, here I have a plan, and oh, I didn't put the max limit tokens. I just make sure that you add that in the feature bar. I'm just gonna leave it as the climbing mountain, just so you have a good example of like what is gonna happen if you send that, because we added a guardrail. Let's go to the next one. The system role now.
So we've seen the power of the system role. Let's now talk about the assistant role. Recall that chat messages are a list of dictionaries, where each dictionary provides content to a specific role from either system, user, or assistant. For singleton tasks, no content is sent to the assistant role. The model uses only its existing knowledge, the system message, and the user prompt to generate a response. Assistant messages are primarily used for providing examples to the model. Recall that providing examples to the model in the form of shot prompting helps steer the model towards more desirable outputs. Providing examples with the assistant chat role is, in effect, a more structured way of shot prompting. For the Python programming tutor application we've discussed, we could provide a few examples of user questions and answers that will be sent to the API along with the new user's question. This will give the application a better understanding of the desired style and tone of responses. Let's give this a go. Between the system message and the new user's message, we'll add a new user message with an example Python question, followed by an assistant message to serve as an ideal response from the model. Let's test this out. The generated content can be accessed with the same series of attributes. With an example to work with, the model generates a concise and informative response in line with the assistant example provided. Like with the shot prompting we've seen previously, we can experiment to determine how many examples are necessary to achieve our goals. Up to this point, we've provided examples in the user prompt and in the form of user-assistant pairs. We can even provide examples in the system message. With all these options, where's the best place to provide examples? If the system must output specific information, or in a certain format, add this to the system message. Consider this a guardrail, which, recall, places restrictions on the model output. Example conversations should be provided as user-assistant pairs, as these will guide the model on how to continue the conversation in the same fashion. Finally, examples can be provided in the user message if the context is important to understand a new question or instruction. This is common in singleton tasks. For example, if we want to create a new job advert for our company, we may need to provide an existing job advert to give the model enough context to complete this specific task. In the next video, we'll bring together everything we've learned about chat roles to build a functional chatbot that can handle back and forth conversations. For now, time to practice.
Yeah, so just to summarize, basically, like the idea is that when you call the API, it's not that the API is going to save your previous message. So then somehow, depending on how is the architecture of your system, you need to save the response of the API, and then in the next request, you need to send the whole history of messages plus your new message, just in case. And that's why we have like sometimes like the role user and the role assistant, because you need to put it in a structured way. Okay, so let's go. So this will be structuring chat messages. You've seen how chat roles sends it on. For examples, you can or the messages. So ordering. So first the system, then is the user, then the system, and then is the user. I'm already struggling with a coding problem. Don't worry, I'll get sorted. How do I access dictionaries by using their keys? Got it. Chat models are great for creating conversational applications, but they can further improve by providing part of the conversation for the model to build on. Okay, so your helpful geography tutor generates concise summaries for different countries. Okay, so I guess that now I need to add like for example, a user. Sorry, it will be role user, and then the content of this will be the first question that the person asked, and then assistant. New role. This should be an assistant, and then this is the content. Give me a quick summary of Greece. That's good. So this is assistant messages. I'm gonna do this. All right. So then from here, I need to copy this part. So in this case, I'm giving like a previous conversation sample, which is like the user asking a summary of Portugal, and then I'm getting an answer from the assistant. So the next question that I ask, like in this case, give me a quick summary of Greece, I get a reference of how does the assistant should reply, apart from the system prompt, which is here, your helpful geography tutor. Python. Whoop. I called it, but I didn't print the response. To do this here, and then I need to call it again. Good. Yeah, so I guess this example is not too clear because uh, mm, the thing with this is that it's trying to give you a reference. Maybe a more extreme sample would have been like better. Like for example, tell me about Portugal, and then it starts and then it starts about talking about geography, and then if I tell me about Greece, I should expect that it tells me about geography too. But in the case that if I don't send that, and if I don't sell this geography tutor, probably will just tell me any fact about Greece, you know. It does, but this is good for now. I'll just finish this. Now I'll probably restart my computer and run another stream after this because this is not working the auto submission and the running here. Okay, in this sample I'm giving more and more messages. Alright, let's just run this fast. So this should be multiple assistant messages. And in this case it's kind of similar, but I'm just putting more and more multiple assistant messages. Let's just do this. Let's your how about your region? Concise summaries of different countries. Give me a quick summary of Portugal. Okay, now I'm gonna do. Give me a quick summary of Spain. And now Spain is a country in Europe that borders Portugal. Okay, France. The capital is Madrid. Okay, and here you're gonna see probably a better example because now I'm just talking about the borders and the capital city. And in the previous example, it was giving much more information than just this. And now you're gonna see that the answer is gonna be more limited, and that's why this is probably a really good example compared to the previous one. So I'm gonna do give me a quick summary of Poland, let's say. Poland is a country in Europe that borders Germany. The capital is Warsaw. And here, for example, is give me a quick summary of Germany. And I can put Germany is a country in Europe that borders Poland. The capital is Berlin. And then when I ask for summary, it's gonna probably just talk to me about borders and capital cities. So let's do this. Let's run the 15. Okay. So no, I guess I guess now it's following the a bit the pattern, but still for some reason it's not like talking to me about the borders. Even if I give like many previous conversations about the borders, which I would expect that it will talk to me first about the borders and the capital city, but it didn't mention nothing about the borders. Well, it's not deterministic, I assume.
Great work so far. In this video, we'll begin to unleash the full potential of chat models by creating multi-turn conversations. We've seen how we can construct a series of messages outlining a conversation between the user and assistant, which it uses to respond to a final user message. The model, in this case, will output a response to this final user prompt. If we could store this response and add it to the messages, we could continue this back and forth conversation with the model. This is exactly what goes on underneath AI chatbots like ChatGPT. To create this conversation, we'll need to code a mechanism so that when a user message is sent and an assistant response is generated, it is fed back into the messages and stored to be sent with the next user message. Then, when a new user message is provided, the model has the context from the conversation history to draw from. This means that if we introduce ourselves in the first user message, then ask the model what our name is in the second, it should return the correct answer, as it has access to the full conversation history. Let's start to code this in Python. We start by defining a system message to set the assistant's behavior. We could also have added initial user assistant example messages here, but we've left them out for brevity. Then we define a list of questions. Here we ask why Python is so popular, then ask it to summarize the response provided in one sentence, which requires context on the previous response. Because we want a response for each question, we start by looping over the user questions list. Next, to convert the user questions into messages for the API, we create a message dictionary containing the question as content from the user role, and add it to the list of messages using the list append method. We can now send the messages to the model and store the response. We extract the resulting assistance message by subsetting from the API response, creating a dictionary so it's in the messages format, then add it to the messages list for the next iteration. Finally, we'll add two print statements so we can see the conversation between the user and assistant written as a script. We can see that we were successfully able to provide a follow-up correction to the model's response without having to repeat our question. You've learned about key functionality underpinning many AI-powered chatbots and assistants. Time to begin creating your own.
Okay. Creating a conversation is as an online math learning pad called Easy as Pie has contracted you to help them develop an AI tutor. You immediately see that you can build this application by utilizing the OpenAI API and start designing the simple proof of concept for the major stakeholders of the company review. Okay. So you have the system, you have a math tutor that speaks concisely. Role user, explain what P is. So I guess I should put this here. I don't know what to do here. Yes, indeed, set the role. In the system dict, set the role to assistant. I store the response as content. Is the append method to add assistant dict. To the messages dictionary. Yeah, so I have the messages. And then I'm just basically from this response I think I'm getting the okay, I got it. So I need to get a response. So this is the response from the assistant. So the dictionary to the dictionary I need to add this new response, and then I'll get the messages. So then I'll have the whole history of the user and the assistant. This is what I was talking about before, that basically what I'm doing is just like I get the response, then the chat is not going to remember, so then I need to save the response that I got, save it into the dictionary, so then I can send the whole list of messages in the next response. So in this way I create an history, right? Because inherently this we don't have an history inside of there. So let's do that, and let's run it in my local machine. And this is called 16 conversation history. And let's copy this. Yeah, it's all copied. And now let's run the 16, and you will see that now I'll have the like in a dictionary with all of the with the system, with the role, and with the system, the user message, and the system message. See, you have three of them. And this is the second one. So this is the first one, second one, and third one. You have all three. Good. So for each message, I'll need to find the role of user and the question. Then on the messages, I'll append the user dictionary. Then into the messages, I'll just put the messages. Then I'll append into the dictionary the message, respond to this message. Then I'll append this. So now, then when you enter to the next loop, I'll get the whole history with the last message of the last response of the system included. Yes, and that will be it. And I'll just do this. Chat bot. So this is a way to do this. And I'm gonna run the Python 17. Name is not defined. What do you mean nameless? For Q in user messages, because it needs to iterate per each. So I get the user, explain what is P, and then it's printing the answer of the system, and then again for the next loop. Good. It's really good. Congratulations. So we finished the course, guys. We finished the course in 1 day of working with the OpenAI API. So that's good. Congratulations. Let's see.
Congratulations on making.
Now the only issue is that I will need to restart my computer and like copy and paste the results that I got, so I can mark checks in each of the chapter and finish this, because I was doing everything in local.
It's the end of the course. You've come a long way. In Chapter 1, you started to learn about the OpenAI API and how to make requests to OpenAI's chat models. In Chapter 2, You utilized OpenAI's chat models to solve a range of tasks, including question answering, text transformation, content generation, sentiment analysis, and categorization. You even learned how to control the model's behavior by tweaking the max completion tokens and temperature parameters. In Chapter 3, we unleash the full potential of chat models by utilizing system and assistant roles. We use the system role to steer the model towards more desirable outputs, and to add guardrails or restrictions to model outputs. We use the assistant role to provide few-shot prompts in a more structured way, so the model has a better understanding of how to continue the conversation. Finally, we created a conversation history and a mechanism to add new model messages back into the history, so the conversation can continue to go on. DataCamp has lots of courses and learning pathways to help you continue your journey and create more impressive and diverse applications, so feel free to check them out. Congratulations again. I hope you enjoyed learning about some of the amazing functionality available through the OpenAI API. Have fun applying your newly learned skills.
Got it, got it. So basically it's good. We finished the first chapter of this. This working with the OpenAI API. Or is the second one? Because the third one is building conversations with the... No, we finished it all. It's just that it's not marked because I couldn't run it there. But basically, now we are doing this path, which is the Associate AI Engineer for Developers. When I restart my computer, I'll just finish this. The next course is Prompt Engineering with OpenAI API. Okay, advanced prompt. We'll do all of this for tomorrow. And also this probably, and then we'll do Hugging Face. I think I just took this somewhere in Spanish, but the thing is that instead of using the OpenAI, we can just use our own like local models. But that's for later. Thank you guys very much for if you're watching this. Yeah, we see each other tomorrow. I'm gonna just keep like practice. I'm gonna first I'm gonna push the code here. And I'm gonna copy the commit here, and this I'm gonna call because this was the second and third chapter. Oh, how come no? How come it doesn't exist? I just saw it. I need to log in, I guess. I just want to put a proper. So I'll call it prompting and conversations. With OpenAI API. Let's push it. So yeah, so let's see each other tomorrow. We're gonna keep pushing, guys. We're gonna keep pushing until we finish all of this path for Associate AI Engineer for Developers. So yeah, guys, thank you very much for watching. You're here for seeing. It was really nice. We're learning a lot every day. Remember now we're transitioning from software engineering to AI engineering. So yeah, let's keep rolling, guys. Every day is a hustle, and we hustle here every day.